A natural force of nature unlike any other, El Nino is capable of unleashing a fury of climate changes and natural disasters that span from Alaska all the way to South America and beyond. What causes El Nino, and how are we affected by it? El Nino is not a storm, but rather a weather phenomenon in the Pacific Ocean. During an El Nino, the surface water temperature warms up, leading to complex weather patterns. South American fishermen in the 19th century, describing warmer waters during Christmas time, coined the name El Nino, Spanish for the Blessed Child. Nowadays, when sea surface temperatures in the equatorial Pacific Ocean rise 0.5 degrees Celsius over their historic average for 3 consecutive months, and once atmospheric conditions and rainfall patterns shift accordingly, scientists officially declare an El Nino. An El Nino event takes place about every 2 to 7 years. Normal east to west trade winds over the Pacific weaken, and warm water that normally travels westward is now moving toward the east. Moisture then rises into the air, and the effects of El Nino are felt throughout the Americas. In the ocean, warm water pushes colder water downward, blocking the important upwelling of nutrient-rich waters from the bottom. This causes some marine life to migrate to colder waters. Animals that normally feed on this sea life suffer, and fisheries throughout Central and South America suffer too. But El Nino's most noticeable repercussions are felt on land. In the western United States and Central and South America, the warm air and moisture lead to increased storms, rainfall, floods, loss of life and property, and the increase of some vector-borne diseases like malaria, even in places where they don't normally occur. In Southeast Asia and Australia, the opposite takes place. These areas suffer from drought, wildfires, and colder ocean waters. In 1997 and 98, the world experienced the biggest El Nino in recorded history. Some estimates blame that El Nino for 2,100 deaths and $33 billion in damages. Mongolia saw temperatures reach 108 degrees Fahrenheit. There was record flooding in Peru. And the U.S. saw storms in the Gulf Coast, flash flooding from California to Mississippi, and tornadoes in Florida. Scientists are now better able to predict if and when an El Nino event will take place. This helps communities better prepare for the changes in weather patterns and better adapt to its repercussions.
All right, hi guys. After watching that little short video clip about El Nino, I wanted to kind of show you this simulation again, just to describe what you saw in that video in a little bit more detail. So if you look at the flow, right now I have that same simulator that we've been using all week long, but I want to show you the south equatorial current that flows all the way from South America over here on the eastern side of the Pacific Ocean, all the way over to the western side of the Pacific Ocean near Indonesia, the Philippines, and the eastern part of Australia over here. And as you can see, we have this cold current that comes up the western coast of South America. And you can see this yellow color here is actually that cold water that sits off the coast of South America over here. And then it flows across, warms up along the way, and pushes all this warm water all the way over into this region of the world. And as you can see, that purple, dark red color showing you the buildup of all that warm water. Now, as a result of having all that warm water normally over here, you are going to have a lot of humid conditions. All that warm water leads to warm air that then is going to cause really stormy conditions over in this area. It's a very wet region of the world. These are normal conditions. So right now it's a normal year, normal stuff going on, and you have this nice flow going across the Pacific Ocean. I said flow. Anyway, over here, it's cold, right? We have these colder conditions, colder water over here, and it's really good fishing in this region of the world normally off the South American coast here. Okay, so these are normal conditions. Now, during an El Nino, this current, these trade winds that blow across here out of the northeast and the southeast, they weaken, and so you have this really like extreme slowdown of this current, and all this warm water that's normally over here sits over here, and so it gets really hot water in this region, therefore stormier conditions and wetter conditions over here in South America, as you saw in that video. So that's during an El Nino. It's just a weakening of these winds and a weakening of this current, and now all this warm water sits here. As a result, this cold water is not going to run up this coastline, and the fishing industry basically dies out. We have a total change in the climate in this region of the world, including up into our neck of the woods up in the United States. So that's what we call an El Nino, also known as ENSO, or El Nino Southern Oscillation, and that happens every 2 to 7 years or so. Okay, so I like the simulation. It describes it pretty well, and I'll give you a little bit more detail as we go.
In this animation, we're going to look at the cycle of El Nino and La Nina. That is a pattern that occurs regularly in the Pacific Ocean and has a huge effect on climate and rainfall and other kinds of activity all around much of the world, especially around the Pacific Ocean. Now, in order to understand the development of these two conditions, El Nino and La Nina, let's take a look at what the normal situation is in the Pacific Ocean. Normally what happens is that you can see those reddish arrows there. You get these very strong southeast trade winds blowing from east to west across the Pacific. By the way, this is North America over here, South America. This red line represents the equator. This is Australia and New Guinea, and Asia would be out of view on this side. So as these trade winds blow, the air eventually rises in low pressure systems and creates a lot of rainfall over on the west side of the Pacific, over near Indonesia. And as that water, and what happens is a circulation cell called the Walker cell is set up here that it basically runs like that. Well, the effect of that is to push the water away from South America. Ocean surface currents are pushed this direction, and that takes warm water and pulls it away to the west, and it lets cold water come up from below. Here we have warm water, the thermocline, the big change from warm to cold, and then cold water down underneath. And as that wind blows and pulls the water away from South America, you tend to get cold upwelling water near South America. Meanwhile, a lot of very warm water accumulates over here in the western Pacific. It's called the West Pacific Warm Water Pool, because that water takes a long trip along the equator and it gets very warm in this area. So this is a part of the world that's very wet and warm and rainy, whereas this part of the world tends to be cool and drier in general. Now, the whole reason this can happen is because these strong trade winds push this water from east to west. But if those trade winds break down, what can happen is all this warm water on this side of the Pacific Ocean can kind of slosh back across and pile up on this side. And that's really what happens during an El Nino. What happens during El Nino is the trade winds actually weaken and break down. It's called the Southern Oscillation. What will happen is that water, that warm water, there's nothing to hold it back anymore, and it flows across the Pacific and kind of piles up over on this side of the Pacific, going all the way up toward California, all the way down to Peru and Chile. And we don't get upwelling anymore over here, and the atmospheric pressure patterns switch, and so what happens now is that warm water fuels rain and storms, and the trade winds are actually reversed in direction, and this part of the ocean now becomes the rainy, stormy side of the ocean. And so during an El Nino, we typically have very high rain and lots of storms and flooding over on this side of the Pacific, from California on down to South America. Now, what usually happens within a year or so after the El Nino is that it's like the pendulum swings back the other way, and we get a La Nina. La Nina really can be considered to be a sort of an intensification of the normal conditions. Remember, this is the normal situation where the trade winds are blowing all the water west and it's piling up over here. During a La Nina, the trade winds blow even more intensely, and even more cold water gets pushed west, and even more intense upwelling happens along the coast of South America. So it really is just an intensification of the normal situation. So the Pacific Ocean kind of oscillates between these two conditions, the El Nino condition, in which the water sloshes over to our side of the Pacific, bringing storms and rain and warm water, and the La Nina condition, in which the water goes back to the other side of the Pacific and cold upwelling becomes even more intensified. These cycles go back and forth, not particularly regularly, but anywhere from every 2 to 8 years is pretty typical.
And here's that same picture that he was showing. El Nino, again, the warm water just sits over here, and you have heavier rainfall in this part of the world. And over here, you have drought conditions because now you don't have that warm water coming across to the other side. A La Nina is the complete opposite, as it was indicated in that video. And now we have just like extreme conditions of this like really fast movement of water across. All the warm water sits over here and colder water sits over here. So it's just an extreme normal condition with a La Nina. Okay. Now, how does this affect us? Well, typically during El Nino years in North America and the United States, we tend to have milder conditions during the winter time, less snow during the winter. It tends to be a little bit wetter in the southern part of the country. So it just kind of pushes all this frigid air further up north into Canada, which I guess in some ways is welcome by some people to have a little bit milder winter around here. And by others like snowboarders and skiers, they don't like this. But anyway, so that's an El Nino. Which natural event periodically weakens western surface ocean currents in the equatorial Pacific Ocean, resulting in a change in air temperature and precipitation patterns in the United States? We just got done talking about that. That is called El Nino or ENSO, El Nino Southern Oscillation. So the answer is number 1. This was a reading. This is actually from a Regents question, I believe in 2014 or 16. Don't quote me on that, but you had to read this, and it gave a lot of the answers to the questions. You have description of normal conditions, and then during an El Nino, and it kind of talks about all that stuff. So if you want to pause that and read that all, that'll give you some answers for the next couple of questions. But the questions are here. Okay, so it says, all right, so this is a picture of normal conditions, right? We have those winds blowing across the Pacific Ocean normally, building up a lot of warm water on this side in Indonesia. Cold water is upwelling on this side in South America. It says, which statement best describes the planetary wind belts that produce the winds represented in the cross section above? So these winds are blowing towards the west, right? So we have winds that are blowing towards the west. So you really have to look at your reference table and look at these winds right in this region. We have winds that are blowing up like this and coming down like that are all moving all this air across the country in this direction or across the world. And so this is a northwest wind and this is a southwest wind that are converging, they're colliding here and running across. You can also look at this picture here. You have this northeast wind and the southeast winds that are converging in the center and blowing across. Okay, so they're from the northeast blowing towards the equator, from the southeast blowing up towards the equator. And they converge here, they're colliding in the center here. And as they go into each other, they go across the world that direction to the west. So we have directly from that page, northeast winds and southeast winds converging and blowing toward the west. That is number 3. That's a tricky question there. All right, 42. Compared to non-El Nino years, which climatic condition exists near the equator on the western and eastern sides of the Pacific Ocean during an El Nino event? Well, during an El Nino event, we have really warm water over here. We have really wet weather over here, so stormy conditions in this part of the world. So on the western side of the Pacific over here, it's drier and colder. Over here in the eastern side, it's wetter, humid conditions. So the answer to that question is actually number 1. Okay, so those are just some like examples of some ocean questions that might be asked. And if you have any questions about any of those, don't hesitate to ask. Okay.